Okay, hello guys. So today we'll be doing a Leetcode daily challenge, minimum number of days to disconnect Iceland. So we are given a grid, 1 represent land, 0 represent water, and on Iceland is a maximal for directionally connected group of 1. So the grid is said to be connected if we have exactly 1 Iceland, otherwise it is said to be disconnected. So in one day we are allowed to change any single cell from 1 to 0. So we need to return the minimum number of days to disconnect the grid. So if the grid has exactly 1 Iceland, then that's where our work beginning, right? If it has 0 Iceland or it has more than 1 Iceland, then we simply just return 0 because it is already disconnected. So when we have 1 Iceland, it can be proven that the maximum number of days to disconnect the Iceland is 2. And why is that? Let's take a look at this example. We have 1 land. We have each of these guys can be considered as a corner, right? So we can disconnect this guy by removing the 2 nodes that are connecting to it, removing this guy or this guy. Now this guy become disconnected from the original Iceland. Take a look at this case. So by definition, then a node is considered a corner if it has smaller or equal to 2 number of nodes connected to it, right? So this guy can be considered a corner, this guy, this guy, this guy, and also this guys. So if it's a corner, then we can just removing the adjacent node that are right next to it. Okay, so when we remove it, the only way to connect to it from the original Iceland is by moving diagonally, and it is not possible since we can only move horizontally or vertically, right? So the maximum number of days to split an Iceland into 2 is 2. So if you're looking at the constraint, it is relatively small and we can actually do a brute force. And what I mean by the brute force is that if you already familiar with this type of question, you would probably stumble upon these guys. Okay, we can count the number of Iceland by doing a for loop, and each time we meet a land, we will do a breadth first search to mark all of these guys as visited and increment the number of Iceland to 1. Afterward, then we just return Icelands. That's basically it. Okay, so we can just like initially count the number of Iceland, and if it is 0 or 2, then we just immediately return 0, and if it is 1, then we will do a for loop. Each time we meet a land, we update it to be a water, right? We update it to be a water, and we count the number of Iceland again. If it's still 1, we continue doing that. If it's 0 or if it is larger than 1, we return 1, right? Because by doing one operation, then we are successfully split the item into 2. right? Then we just immediately return 1. After exhausting the for loop and returning nothing, we just return 2. Why? Because the maximum number of operations to split an island, to isolate, to disconnect an island is 2, right? As I previously said. So we will start by defining a function called counts island. So we have a visited set. This will store a set of nodes that has already been visited. We have a variable called island to keep track of how many islands we stumble upon. And then we will have to do this first. Grid length grid 0 for R in range R, for C in range C. If RC not in visited and R grid RC is a length, added to queue. Oh no, we'll just do a BFS RC, increment the island by 1. Afterward, just return the number of islands. Now we'll have to define our BFS function. Have to define the direction that we can move, which is we can move to the right, we can move up, we can move to the left, and we can move down. We define a queue. That's basically how we do a BFS, right? We have to maintain a queue. This queue initially will have RC. We will add RC to our visited set of visited node, and then we will do a for loop. For direction, for dr dc in direction. Then the new row, new column would be equal to queue. The current node is right. If the new row and the new column is still inbound, what I mean by that, if it's larger than 0, smaller than R, and new column smaller than C, and new row, this guy has not been visited, right? And it is a length. We add it to the queue. We add it to visit. Right. So that's our counts island function. So initially then we have to count the number of islands in the original grid, right? So if island is equal to 0 or island is actually larger than 1, right? So we just return 0. L, then we will do a for loop for R in range R, or C in range C. If grid RC is equal to 1, we will update the grid to be a quadrant. We will do the counts islands again. And then if island is larger equal to 0 or Iceland is larger than 1, it means that we have successfully disconnected the grid, right? So we just return 1. By doing one operation, we successfully disconnect the Iceland, we just return 1. Else then we just update the grid back to be the LAN. After exhausting the for loop and returning nothing, we just return 2. And that's basically it. Okay. Yep. Okay. So time complexity of this obviously would be n to the side of n, right? Or square. Why? Because our count islands is m multiplied by n, and we do another for loop that's also m multiplied by n, so that mn square, right? And for space complexity, basically then we need to maintain a set that's just m and n. Okay, hopefully it makes sense to you guys, and thanks for watching.